And that's all we need for the sprite data, for the game data ASM. So back in our main, like I say, I like to keep this tidy. So that would be our main entry point for any next app. And then sitting next to that, I'm going to have another file called game.asm. This is going to be our launch point for our game rather than our app. It's a bit of nonsense what I was just talking there, really. It's just a way of tidying up, not having everything in main. See, now we can just have game start, game update, game draw. We've made a little game loop there. Of course, start just gets called one time when the game starts. This gets called every frame, followed by that every frame. And how we do that is in our start here, we just simply call game start. Let's do jump main loop, just in case we accidentally put something there. Game update, game draw. Okay, and in your main.asm, let's include those two files we just created. Make sure that game data.asm is at the bottom. Something to do with the fact that we're opening these pages. without closing them. Probably. I'm not an expert on them, but just if you make sure that's at the bottom, it's going to be fine. Alright, so we've just, whatever the word is, like, extrapolated, maybe. I'm just guessing that, but we've moved away from main and left it as a little closed file now. Really, that doesn't ever need to be changed. You could make any game and just copy that into every one. Starting with this then. So we need to check out the board register, or the board feature control, as it's called on the website. Brought it up already. So specnext.dev/board feature control. And underneath next TB blue features is what we call nextregs. And they're numbered. And the ones we're interested in right now are going to set up our game window. So the first one is 1.5, Sprites and Layers System Register. Here there's some advanced stuff like low res. I haven't looked into that yet. So you can flip the rendering priority. That's probably wise to do. I like having front layer being 0. Like I say, we don't have to know what all them do right now. You'll know when you need them. But right now we want to set over the border and sprite visibility true. We also want to look at this layer mixing and see which one we want. For us it doesn't matter right now. We'll leave it at a default 0. So we just want 0 and 1 to be set. And it's really simple to do that. Just nextreg 1.5 and then the binary like that. Okay. Next one we want to do is nextreg 4.3 enhance ULA control. Well, I have it in my notes that we need to do that. Maybe we'll try and not use that. I don't think it's necessary as a base example. We'll have to find out in a minute. Now this one, 6.8, let's have a look at this one. That's what we need. Okay, so you'll notice we've disabled the ULA. Again, I'm not sure of the purpose of that, but I think it created glitches like with the code. It started working on the wrong screen memory when we were trying to use a tile map. So again, it might not be necessary. Let's try without it. And let's pop that in there just in case we do need it in a bit. I don't think they're essential. Right, next we'll set A to be 0 by doing X or A. And we'll do 4C 0. Well, again, not needed. It's tile map stuff. Leave that. But The next one is okay, so that's the global transparency, which is nextreg 1.4. Global transparency register. I'm just thinking, I don't think we actually need that either. Let's just comment it out for now. Try and get it down to a bare minimum. Nextreg. The next thing we want to do is, sorry, not nextreg, is write a Sprite Init function. I wouldn't usually write this in my game assembly file. I'd normally give it its own file for tool, like a tools file or something. Right, now this is slightly more advanced than your average beginner's lesson, because immediately as soon as we open this routine, as soon as we call it, we're going to push BC. And the reason for that is we want to store what's in there, but then we do want to use BC as well. So you'll see what I mean by this in a minute. Load A0 is the same as doing XOR A. In fact, let's change that. Why not? Stick with the same way. .303B is the port which you write to signal that you're about to write sprite data into the actual internal memory of the FPGA or whatever it's called. So sprites actually have their own hardware memory which you upload to. It's not in the normal 1 megabyte of RAM. Or 2 megabytes if it's extended. But to write to it, you do that, Alt C A. Then we'll pop BC back. So we've now used BC, but we've managed to store it so we can load it before calling this. We don't want to make a loop. The dot signifies that it's a local label, so we can reuse the name loop as long as it's inside a different routine. So store BC again by pushing BC so we can use it. Okay, so that goes in sequence and outputs. Does out CA, but this time it's got that value in C. I believe there is probably a better way of doing that, but it does the trick. So anyway, you don't return there, you do a DJNZ to the loop. So that's why we popped BC. Now B will count down until it gets to 0 and then we will return. And the way we access that, or the way we want to call this, is we first use nextreg. Where did we put it? We put it into bank 6, 14. So it's nextreg 5, 6. It would be 5, 5 if you put it into bank 5. Page 14. Now we load B with sprite count, so it's only going to do it one time, but if you had 64 sprites, it would do 64. We'll load HL with the memory address where we want to begin in the page. We can finally call init sprites. Okay, so this is going to increment HL. My code lens might come up and tell us actually. Surprised it doesn't. Because this extension here, code lens, usually you hover over that and it tells you exactly what it does. But there's a website called Z80 Heaven I like to go to. I don't know exactly what this does, but I can tell by the name it's outputting. And it's going to increment HL and BC. I've got to look it up now. I was trying to avoid a pause in the video, but I've ended up waffling instead. So it reads from HL and writes to port C. HL is then incremented and B is decremented. And it repeats all the way till B is 0. So we've got two loops inside each other there. Or one loop inside the other. Okay, and then the last thing we want to do is just have a draw player routine. And like I said, this is going to be just the most basic way of doing it. Next session we'll be looking at moving them about, having more than one sprite, and lots of other slightly more advanced topics. But for now, I'm trying to show the absolute bare minimum as far as I can tell to do it. So here is the slot. Oh. And you'll be able to look up the nextregs. I've showed you the page to look it up on. I'll show you one more time. It's 34 actually. Show you one more time. Yes, this page here. Right. And as you can see, look, 3.4 is the mirror index register. Select sprite to be affected by writes. That means it's waiting for you to write these in order. And you'll see I'm just about to do that now. So we're in slot 0 for our player. We'll load A32 for the X position. Like I say, it gets a tiny bit more complicated for the next session because X is actually a 16-bit number. But you only load the lower byte of it here. But don't even worry about that just yet. I mean, if you're watching this and you're thinking, well, I am worried about that because I know how to draw a sprite, but I wanted to know how to handle the 16-bit. A lot of my videos do have that covered, and my next recorded video will as well. But anyway, while I was waffling, I'd done the Y as well, at also 32. Let's change that to 128. Now remember, we've done the full screen rather including the border. So the height of the screen is actually 256 and the width is 320 now. Alright, the next one is what's called attribute 2. And we'll have a quick look on here. This is another web page you're going to have to get yourself familiar with. That's the Sprites wiki, or whatever you want to call this. Pattern number. That comes in a minute, but that is basically, you know, we've only done one sprite, and that's one pattern, and pattern 0. But you know, if you had 63 or 64 sprites, it'd be a completely different pattern offset to get to the last one. Don't even worry about 4-bit sprites right now. Don't even worry about the palette, you can leave that at 0. Here we go, attributes. We've just done 0 and 1. This is badly laid out because sprite 0 is this. Attribute 1 is that. So we're now on attribute 2. We've done the X and the Y. Attribute 2 is a little bit more complicated, look, because you've got 4 bits here for the palette. Then you've got the 2 mirror bits. Then you've got a rotation bit, which rotates 90 degrees. And then you've got the upper bit for X, which we're going to ignore today. And we're going to ignore all of that. It can be all 0. So let's remember it's going to be 0 and look at attribute 3. Visibility. Well, that needs to be 1 or we won't be able to see it. The extra bit is, so that's telling the sprite hardware that you're about to include this. And what this basically does is allow you to have relative sprites, but also even if you don't have relatives, you can use magnification. This also will be needed if you were doing 4-bit sprites, because you need it for that. Same as if you had Y being able to go higher than 1 byte. You don't need that at the moment. Let's just have just 3. Make sure that's a 0. And then the pattern. That's the rest of it. And we've only got 1, and so that's 0. So we only need that bit there. Okay, so we got slot. Sprite pattern slot, because I don't want to get confused with the bank slots. Xpos, I'll put LSB, least significant byte, just as a reminder. Ypos, we're only going to have it as 1 byte anyway. This is attribute 0. This is attribute 1. So now we're on attribute 2. And we've already said it's going to be 0. And just to be in good practice, why not make that X or A? Get into the habit of it. There's other little tricks you can do as well. That's just one that's stuck in my mind to do. It's the same as writing load A0. Finally, we're going to load A with that 1 visibility bit and the rest zeros. And there we go. This is the very most basic way of doing it. They're all hard coded. Next session we'll be making a player class and interacting, with drawing this every frame. But right now it's not going to move. It's just going to be Mario stood there, I should say. Called draw player. Should be sufficient. And because I've already included them and called them, we should find this is good to go. You'll notice we didn't use these, but we will do soon. Let's give this a whirl and see if it works. So invoke item run.bat. Oh, I've got an error. The error is game.asm line 9. I put a percentage sign. It should be $1. Note that OX is also acceptable there. And actually, in a lot of compilers, you could just write a H there. Let's see if it allows that. I don't know if this allows that. Yeah, that is fine. So now we've got it. And we go into our browser. And there's Mario. Right in the middle of the screen where we fought. Of course, I didn't take into account his width and height. But if you want him to be dead center in the middle, you could do 320 divided by 2. That's the middle. Minus 8, because I happen to know he's 16 wide, so and then there you go, he'll be in the middle now. There we go, dead center. Now, just as a quick wrap up, let's put that extended bit in. You'll note now it'll probably just be a 0. It might even be an error because I didn't include attribute 4. It hasn't caused any noticeable error, but if we flip back to here a sec, attribute 4. Let's say we want to magnify him by 8 times, make him 8 times larger. That's much bigger. We need 1s for all of them. Of course, like I just said, we need to make sure the extended bit is set. And then that ought to do it. And because, like I say, we've set that extended bit, it's waiting for the nextreg 39 to be written to. He should be pretty goddamn big now. He might even be too big for the screen from where I put him. Oh hey, there he is. So you can make some pretty cool effects with this magnified because the game can zoom in quite far. I mean, I don't know how it works with the tile map and stuff, but it's still pretty fun. Because this is actually only taking up a tiny bit of sprite hardware memory, you see. So you could still have a lot of animations in there. Just not much detail. I mean, we could also have rotated him, turned him upside down. That was in attribute 2. If we want to rotate him 90 degrees, that's an easy one because we just rotate bit number 1, or set bit number 1, I should say. So we'll have to change that back to that. So he should just be rotated 1 time now. Soon we'll load auto exec.bas and you won't have to flip through this menu. Oh, he's rotated, but because he's so large, he's not even visible anymore. That's an interesting side effect. We'll deal with that another time. Oh, in fact, I've set the wrong bit. I just set the X upper byte that I told you not to worry about. We'll be looking at that in more detail next time. There we go. So finally he's rotated. And if we turn the rotate bit off again and the 2 adjacent ones on, he should be completely flipped. Well, hey. Of course, you might, that's not so useful. You might only want to flip him on X. So get rid of the Y flip. And there he is. Simple stuff. We're going to be doing more detailed next time. I think that's a good place to wrap it up. If you have any questions whatsoever, give us a drop in the messages. Myself or part of the small community we got here, they're all a helpful bunch. We're live on Twitch most nights. Sporadically nights off when I feel like it, but regularly on there in the evenings, sort of after 11 o'clock. And I'm interacting with all the viewers there, so come in and say hi. Other than that, enjoy yourselves and wait until the next video. It's going to be coming soon. Next one we're going to be doing a more detailed look at sprites and making an array of sprites all moving around independently. Okay, have fun. See you soon. Bye bye.